That would be factoring. Occasionally you might be asked to factor an expression, which is just going all the way back to the original terms. Often this is done to find a root or a zero of a function, but they could just say factor this expression. So if we started with this expression, we know from the work with foiling that two things had to multiply together to give us the x squared. But also, two things had to multiply together directly to give us the negative 15. That's actually a better place to start. The negative 15, well, that's got to be two numbers that directly multiply to give us that negative 15. It could be a 1 and 15, and of course, one of them would have to be a negative. It could be 3 and 5, and again, one of them would have to be negative. Or flip-flopped, right? Whichever one was negative before could be flipped to positive. So these are the pieces that would have to multiply together using whole numbers to give us that negative 15. And we assume until told otherwise that we are multiplying out whole numbers, and especially because that 2 in the middle term adds up to such a clean value. It's not 2.25 or 2.71 or something messy. Well, then that means that positive 2 was from combining like terms. When we FOILed out whatever this thing is we're solving for, we would have gotten those two values, then combining those like terms would give us the positive 2. So which row in the table we just made gives us two values that when we add them together, the sum is positive 2. Looks like negative 3 and 5. So negative 3 and 5 are what has to go inside the binomial. So this is how that binomial must have originally looked. And we can also FOIL it back out. Foiling this back out had better give the original expression we started with at the top of the screen. Let's double check. X times x is x squared. Yes. X times 5 is 5x. Negative 3 times x is negative 3x. And negative 3 times 5 is negative 15. Adding those and combining like terms does give us x squared plus 2x minus 15. Whew, good thing we double checked. Now, again, this is a great way for you to double check your work, but it's also a way that we could start from the answer choices and check each of them systematically if we were really not feeling confident in going quickly through a factoring on test day. Either one of those you should try for number 5, either directly trying to factor or using the answer choices to get close. Good luck. Let's take a look. My preferred way to do this would be the direct math, trying to solve for what we could multiply together to give us the 16 should allow us to start finding the values inside each binomial. So 1 times 16 would work, 2 times 8, 4 times 4. Even at this point, I could probably get rid of C and D. In C, 4 times 6 is 24. That's not right. And in D, 10 times 16 is 160. That's also not right. It actually has to be A or B already. They're the only ones that have part of the binomial where the second term would multiply to actually give 16. That's a good elimination, and if I was short on time, it would have gotten this down to a 50-50 guess if I had to guess and move on. Now, we don't have to guess, because we know the next step. Which of these adds up to be positive 10, since that's the middle term in the expanded form? Well, 4 and 4 doesn't, but 2 plus 8 does. So it must be that the factored form is x plus 2 times x plus 8, and that's a match to answer choice B. Now, as a reminder, we could have actually, especially after getting rid of C and D, just taken A or B and FOILed it out. Whichever one gave the correct answer that we started with would be the right answer. And if one of them clearly gave a wrong answer, we also know a third wrong answer. If you can work on a problem and get rid of 3 wrong answers, whatever you're left with must be the one right answer. It's a nice way to do it as well. Now, last up, in terms of application, the reason that we might want to factor is because we're solving a quadratic expression, or solving that expanded form. you might want to solve if we're trying to find which values give us 0, what are the start and end points of a relationship, what are the values that you'd have to sell in tickets or apples or goods in order to break even. These are all variations of the 0 problem. So let's suppose we took that problem from earlier and we were trying to solve for the zeros, or solve for the values that make this true. Now we've already done this, but we would be factoring this out. So factoring it to the x plus 5 and the x minus 3 form, and then truly solving is solving for each of those parentheses. So the x plus 5, if that term could become a 0, then the whole expression is 0, because 0 times anything is 0. So if we took that piece, that solves to be x equals negative 5. If x is negative 5, then that is a 0 of this expression, meaning the whole expression becomes 0. Similarly, x minus 3, if that piece is 0, then similarly the whole thing is 0. So that means x equals 3 is also another solution. It's another root or another 0. We would write that out by just saying x equals negative 5 and x equals 3 are roots of the equation, or solutions of the equation, or zeros of the equation. Any of those are really the same thing. Let's try this for problem number 6. Go ahead and freeze, attempt to do the factoring, solve for the 0, and then we'll review together. Now there's something a little bit sneaky on this problem, and the sneakiness is, if you notice, answer choice A, C, and D all look very, very similar. Positives versus negatives have been flipped around a little bit, and if we were going a little bit too fast or maybe carelessly, we might end up with an exact wrong answer on this one. So careful scratch work, paying attention to signs is of the utmost importance. Let's dive in. If we're factoring, the first step in factoring is deciding what could multiply together to be negative 12. That's 6's and 2's, or 3's and 4's, or 1 and 12, but no matter what, because it's a negative, half of it would have to be negative. Positive 12 and negative 1, or negative 2 and positive 6, whatever it is. The second piece, though, is they have to add, when we combine, to be 4, because that middle term is 4x. So I have to have numbers relatively close together, like 6 and 2, and they have to have the positive 1 be bigger. So negative 2 times positive 6 does give us negative 12, and negative 2 plus 6 leaves that remainder of 4 being positive. Now, that negative 2 and positive 6 is not the answer we're looking for. Answer choice C is probably the most commonly chosen wrong answer by factoring correctly, but not solving for the solution. The solution is when x minus 2 is 0. So that would be a positive 2 value. And then x plus 6 equaling 0 would be a negative 6 value for x. That's a match to answer choice D.